Welcoming me today's session. So, good morning, everyone. So, I will not take you through a lot of GANs and all those things. Probably you people are. I am hearing from Divya that you people are tired of listening. So, I will take you through a typical case study like how to solve a business problem because see that's the basically difference between what theoretical research works and what basically practical because lot of things we see that which works in basically theoretical framework but it is not working in practically maybe in practically letting getting data for such kinds of things is very difficult as far as the ml practicing is concerned and before that like I will tell you like a lot of people are talking about like machine learning, deep learning, reinforcement learning, lot of things because but still if you see the basics which is basically descriptive statistics, inferential statistics uh, and traditional regression based approach which I think some previous speaker has already talked about explainable AI and all these things. So explainability is a big part, so that's why you if as far as in industry the more simpler is the model the better is the explainability. That is the key mantra. With that I will start this session. So and before that always remember one thing which I want to remember in my entire lifetime, which is the Occam's razor. Occam's razor is basically how much parsimonious your model is, that will be the better in terms of accuracy, better to tune, better to maintain, and better to explain to the normal audience. Okay, with that I am starting my session. Yeah. So I will typically take you through a typical response propensity modeling in machine learning in retail. So here it is a big like a typical traditional approach. If anyone has anything, just you can pause me there also, or you can like asks after the presentation is done. So I will try to complete it within 50 minutes, and so that I will take 10 minutes Q&A session if anyone has anything doubt related not only this apart from any other things like how these things should be tuned, how these things should be in machine learning, how it will do. So here I will do typically a typical like a classical framework, classical classification framework use case. Let me put in presentation mode. Okay, so basically this problem is, see in real life the problem is not coming to you, okay I want to develop a classification model. Probably you have seen those things in Kaggle and those things. This is a typical business use case which I have solved few like weeks ago. So this is the target DM. So what happens is basically a lot of people, let's say in a typical business case, the business people come and say, hey, my marketing budget has increased a lot. I spend a lot of budget, let's say probably $1,000, and but my return of investment or the basically response rate is not coming as good as it is expected. So what is your suggestion? So this is the typical the business problem. It came to me. It nobody told me, oh, you build a classification model, you build a basically regression model like that way. Okay, so having said that, how do you this then basically solve this problem? Okay, so then first thing is you have to understand that how many people you have sent these messages. That is your first question. Let's say these people have said, oh, I have targeted around 50,000 people. Okay, that's fine. What is your basically campaign window? That means which time period to which time period you have sent. Okay, so then he said like, oh, I have done probably this thing. So why then the things are not going good? Is it because of the seasonality? uh, let's say you are doing a promotional campaign for the sweater kind of thing in summer time. It is not the right time because it's a seasonality is the key factor, right? So you have to handle somehow those kinds of things. So a lot of business question you have to ask. So here the thing is basically target this is a typical like a target use case, which is the retail company. So they basically send the direct mail and recipient marketing campaigns and send out several offers to the gift. Now whom to send, what to send. Okay, so here what we are trying to do is basically trying to find out like with the modeling approach how do we solve this business problem, like how we better target the people. That means we will target, so it is a typical Pareto framework, like we will target 20% of the people and we will get 80% of the revenue with how. That's the basically objective. Now, any kinds of models, basically, whenever you see in your real life use case, either the dependent variable is either continuous or the binary. If it is a continuous, then it is a basically regression based problem. Now regression, you can say, oh, I will do the Poisson regression, I will do the basically OLS regression, a lot of other stuffs regression is there, so that I am not going into. But holistically, you can take the things into the two parts. One is basically continuous case and binary case. Binary case, probably it is logistic regression, all other decision tree, random forest, XGBoost, all other the blah 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 machine learning models is there. But you can classify majorly into two category. Now the thing is, basically here it is a, I have solved this problem is typically logistic regression use case. Maybe a lot of people who are basically deep learning and reinforcement learning and all the Bayesian framework, whoever is doing, they are still thinking that why I have solved this problem with a typical logistic scenario. Typically, you believe me, in the industry, 90% of the problem, whatever it is your real life data, you can solve through a typical simple logistic regression framework. If you are not able to solve, then problem is with you. It is not the problem technique. I have worked till 9 hours. I never 9 years. I never see that. Oh, I have used something very great technique, let's say extra tree classifier or something. My accuracy bump up from the 70% to 80%. It never happens. Never happens. If anyone is telling that it happens, that means he is bluffing. Okay, so if you change the technique, keeping your variables as a constant, maybe 3-4% extra accuracy you are getting. So you should, in your practical life, whenever you are trying to solve any business problem, always our focus should be not to use a sophisticated model. Always our focus should be, how do we create a feature? Your feature engineering will be the key part of the entire modeling exercise. That is like bread and butter for everybody. Now, how do you create the features? You will be able to create the good features only when you will have a very good business problem. Okay, as an example, like let's say I am, let's say everyone is using credit card. Now somebody is using Standard Chartered credit card, somebody is using HDFC credit card, somebody is using Citibank credit card, somebody is using HSBC credit card. Now uh, how do you differentiate the different credit card segments? So there is something called transactor and revolver strategy. So if you don't know business, then you will not able to come to know. So how do you differentiate those transactor and revolver? So transactor are basically whenever your credit card billing cycle happens, so basically you keep on paying the bills on time. That is basically your transactor case. And revolver, what is revolver? Revolver is basically who keeps on paying the minimum amount. Whenever you see the credit card bills, so you keep on paying the minimum amount and you deferring your entire full payment in the next month, then again next month, then again next month, like that. So basically that means how much amount you are paying, that is basically a very good key factor. So how do I come to know this? Through feature engineering? No, this is my business knowledge, because I worked in the credit card retail industry for a few years. So with that I came to know. So if I use the proper feature, irrespective of any technique you use. So this is a very new things which I am telling. Probably you are hearing, oh, a lot of people are talking about very big techniques. So then why he is talking about very simplicity? If you understand the simple things, then you can understand this, because I don't see, frankly speaking, if you understand the mathematics behind every algorithm, I don't see that any tree based or anything they are doing very great thing, which our traditional regression based like approach can't do. That's what. Okay, anyway, so here the main question is basically why logistic, why not OLS? Because uh, so it's basically a like in mathematically, whoever is a researcher, probably they can relate the things more. So in mathematically, this is a typical GLM framework. What is the GLM? Basically it is a generalized linear model framework, where y, we are trying to model y where the variation happens. We are trying to model y with respect to x. Now how do you how do you know that x versus y relation? That is basically called canonical mapping function. Okay, in mathematically we can say. So if you do OLS, then you cannot map one-to-one mapping. So that in different kinds of mapping is there, one-to-one mapping, bijective mapping, surjective mapping. So this is a discrete mathematics class. Anyway, I am not going to that. So if you do the OLS, you cannot. So a lot of people I have seen in blogs and all, it's very simple, like the way they are saying, like if it is a discrete, then we are not able to model it. Why we are not able to model it? I never see nobody talks about that. So these all are the marketing. So if you know mathematics, like why we are not able to do mapping, because the reason is it is a discrete set and your x is a continuous set. So your one-to-one mapping will not happen. If your one-to-one mapping will not happen, then it is basically not happening. Because a discrete set, how it will map to the continuous set? There is no mapping function evolved. So that's why OLS cannot do. So the logistic regression, whenever you happen, so it converts the discrete case to the, when you do the basically loggers, it converts the discrete case to the continuous case. Now now your left side is also continuous, your right side is also continuous. Now you can basically do the one-to-one mapping. Then that's why you are able to do logistic. Why not OLS in a typical framework? And the distribution framework is also different. That is another statistical thing. Like in this is whenever you do your left side, it is a discrete framework where it is following a logistic distribution, and in the your independent variable, it follows the basically your Gaussian distribution. So it cannot map. So your canonical mapping is basically trying to understand why one-to-one mapping between your dependent variable versus independent variable. That's how we should do the classification framework, logistic, decision tree, all these kinds of things, not the regression based framework. That's what I explained in here in simple words. You can go through the slides. Yeah, so this is the typical like industry framework, like how we develop the models. So this is the typical data preparation framework, data analysis framework, model development, interpretation. So this is the basically main thing. So interpretation, lot of people are talking about now these days are XAI, explainable AI. So this is nothing but simple model interpretation. How do you evaluate the model? How do you interpret the model to the business people? Because they, if you go and tell them like, oh, 1 unit increase in this, my y will increase e to the power something, then this business people will say, what are you talking about? Like, what is this e to the power and those things? So interpretability is the utmost thing. So whenever you try to interpret, you see that every one of us get stuck. Oh, we are not able to interpret in a very simple time. So that's the basically key thing, and this is a basically model validation. So I will talk about those things. So data preparation is basically how do you clean the data. Your data is not clean, coming in the clean manner. Okay, that is the, so 90%, believe me, your entire modeling exercise in corporates, 90% we will be doing this part. Then 5%, around 7 to 8% is this, around 2% is this. But this is a very important field. So this is all I'm talking, like whenever we are going for the industry, what kind of problem, because a lot of things we thought about, like we will apply this algorithm, that algorithm, but to apply that algorithm, your data has to be prepared, your data has to be cleaned. So that is basically, that's why we should know coding very well, okay, along with the mathematical thinking. Okay, so this is the data preparation, like you have to clean the data, you have to make proper, let's say for a database, let's say a customer ID, you have a customer ID related data, transactional data. So you see that a lot of duplicates are there in that data. Okay, so then your data is not clean, you have to dedupe the data. So do deduping, transforming, missing value treatment, outlier treatment, holding out sample. So how do you define your sample? Whether are you going to develop the model on the entire data, or are you going to develop the model on the sample data? Whether your sample is the representation enough of the population or not, that is your basically that is your typical basically framework of your statistics. Your population should be, must be representable enough for your population. Now next thing is basically data analysis. Data analysis is what kind of data analysis? You will do univariate analysis, you will do bivariate analysis, you will do basically like a lot of weighting scheme. Like previously when we started our career, a lot of like how do you do that weight of evidence, information value, Then basically raw correlation checking, like how the dependent variable versus independent variable, then VIF and multicollinearity. So these days I see that a lot of machine learning practitioners, they are talking about, oh, if there is a multicollinearity, I don't bother because our tree based algorithm don't bother about the multicollinearity. But this is a typical scenario where I faced, I think few years back. So there is two variable called uh, sales 12 months and sales 6 months. Okay, both variables are coming important. Now the immediate business people who are in the business, they are asking, how come 6 months variable and 12 months variable both are significant? Why both the variable? I understood that because somebody's sales last 12 months is very important because they are the very recent customers. So how the both the variables are coming as a significant variable? What interpretability, what action you are going to take for them? I was clueless. I said like this is what my model is giving me as a variable importance. Then what is variable importance? He is asking. I said this is my model is telling this is the important variable. He said absolutely bullshit. It does not make any information to me. Either you tell me that net sales 12 months is important, either you say that next sales 6 months is important. But how both the variables can be important? But what I didn't say anything. I try to defend myself. But when I go to the after the meeting, I go back to my desk and I did the simple correlation analysis and all. I see that my models, both the variables VIF is very high. So it will not impact your model. So that's why your basic is basics. How much complex model you are using, it does not matter. Your basic should be very clear. So okay, that is a variable level interpretation. But if your model is basically high multicollinearity, then your I don't know how many of you people know that if your model have a very high multicollinearity, let's say two people are similar kind of variable, their variable importance score is basically let's say 100. Okay, and now two variables are coming, then their variable importance is separated. Everyone is like 50-50. Now 50-50, due to that, when you do the basically variable importance in descending order, when you sort them in descending order, you try to see, then their variable importance score got decreased, right? So a lot of impact is there. But those machine learning, because we think now due to this advancement of Python R, we think this is just a function like data preprocessing, input, output. No, this is not the case. We have to understand each and everything, like how it is happening. Okay, so that's how the data analysis and all those things which we are doing. Then model development and interpretation. This is the most trickiest part. So recently I was working on a research paper where feature selection is the main key criteria. Feature selection means what? How do you select the features? Let's say in typical our use case, like a credit card use case, 2000 to 2500 initial level of feature we have. How do you know that from there are you going to take 2000 feature and as your model in your model? No, right? Then you will have to probably 100 or 200 kind of variable to start with your model, but that will take a lot of time. Then how do you, maybe you are getting a like a out of memory error, because I am dealing every day the data with 1 crore, 2 crore, 1 crore, 2 crore rows and 2000 to 2500 column. How do you deal with? Maybe you are expert in machine learning, but how do you deal with such kinds of practical cases? So you have to do the feature selection before putting the data into the machine learning problems. How do you do that? Lot of methods are there. One of the method is basically use the multicollinearity variable, removing those, then basically binning is weight of evidence method, information value method. Still people are doing. You believe me? And finance is the one field where monetary transaction is there. That is the most sophisticated part of the data science. I don't know how many of people will be agree or not, because in retail, in any other kind of industry apart from BFSI, banking, financial industry, and like institutional services, except BFSI, go to any other industry, nobody bothered about the explainability. How much people are talking? That is the ground truth till now. But in BFSI, once you develop the model, Then the model will go to the model validation team. Okay, so model validation team means whatever the model you have developed, that is the only industry who will check that what model you have developed, why you have developed everything. Once I develop the model, 6 to 7 months one BFSI model needs time to develop. Then after that, I have to write 100 to 200 pages document. Why? Every step I need to document. Why I have done this? Why this variable I have taken? No other industry. I worked in retail. I worked in CPG. I worked in like energy utilities and all those things. No industry do that. So modeling in BFSI is the utmost critical job. Then like RBI kind of thing, there is a regulatory body for all the model. If you do any such kinds of like a gender bias, let's say you decided you will give loan to the female or only to the male, if you do any kinds of gender bias related discrimination modeling, they will charge you a lot of fine to the bank. So it's not that you have developed something, it's give me good accuracy, it is good. A lot of things we need to take into account. So those business interpretability, multicollinearity, stepwise regression, variable meaning, weight of evidence, all those things come under how do you select the variables. Okay. Then all these things are related to the like a model fit AIC, like how do you feed the model with what is the significant test, whether they are t test or like a Walt chi-square statistics, odd ratio, concordance, discordance, then Hosmer-Lemso test, how good the model has a good separation power or not. Okay, so all those things still people are doing. It is not that machine learning we have forgotten those things. Then model validation, it is still holding still now. So in machine learning, probably machine learning people, because I am still from the very statistical background, so I still prefer those kinds of things. But in machine learning, you people call it as a data drift and model drift. Okay, so this is nothing but this. This is nothing but this. Data drift means what is that? Data drift means your X has distribution change. Let's say today you have developed a model. Let's say in before 2020 pandemic came, you developed a model. Now your pandemic came and now people purchasing power change, right? Whatever previously your one important variable, let's say your income is an important variable for your model. Okay, now previously when you develop the model, their income varies from 20,000 to 2 lakhs people, monthly income for the people. Now when pandemic came, their income distribution shifted to 20,000 to 50,000. Then model is not performing good, right? So that thing is called basically your data drift. Model drift is your y distribution has changed. How do you do that? Basically in our banking and finance, we typically monitor the model. No other industry monitor the model. How do you monitor the model? Monitor is basically something called PSI, population stability index. You will check, like what we will do is after every month we are scoring the model. Once we score the model, we find out what is the population stability index. That means how much stable the model is, in simple words, if you make the business to understand. Now if the population stability index is less than 0.1, your model is absolutely perfect. If it is between 0.1 to 0.2, slight modification is required in your model. Some variable needs to drop, some variable needs to add or something. If it is greater than 0.2, entire modeling exercise you have to redo. So that's the complexity of the developing any kinds of machine learning model or statistical model in banking. Okay, so in model validation, the same thing, like in time validation. Probably you have doing the out of time validation before pandemic, it is doing good. So again you are checking on pandemic, the data is not good. So in time validation, outer rank ordering. So when you sort the probability in descending order, so let's say in first rank you are capturing 10% people, next rank 5%. So it should be monotonically decreasing order. That's what rank ordering which happen. Actual versus predicted. The Lorentz curve is nothing but basically, sorry, your Lorentz curve is nothing but your basically gain chart and lift chart kind of things. I will explain in detail. Misclassification analysis you can find out through confusion matrix and all. Model comparison, you develop 10 models. How do you compare the best model whose AIC AIC information criteria is basically minimum? So a lot of all these things are basically model building block. How much time I have taken for this? Okay. So this is the basically process for the developing any logistic model, but I don't think few steps are removed in the logistic model, but rest of the things everything is okay. Like data cleaning for the preparation, then selection of the variable, then creation of the new variable, that means new feature you created, then treatment of the missing value, selection of the development of the validation sample, that means what is your in-time validation, what is your out-of-time validation, raw correlation checking. Fine classing and coarse classing in machine learning, it is not required. You just create the dummy and it is done. Dummy correlation check, that is also in machine learning, it is not variable importance. You can do stepwise regression. Still I do, because I don't believe on the machine learning variable selection things. I still do the stepwise regression. Whatever the stepwise regression variable is coming, and whatever the variable importance I am getting from the machine learning, I do the intersection, and whatever the intersection variable is coming, that I am taking into the my machine learning model. So that's what this kinds of thing nobody, no blog will tell you. You if you ask only the industry practitioner, they can tell you the how to do the proper feature selection kind of thing. Multi-collinearity check, from there whatever the variables I have got, then I remove which multi-collinearity is probably 2 or 3, whatever maybe, or 5, something like that. Then interpretability the value, then you finalize the model, then you do the validation of all the model. Once everything is right, then you will say my model is ready. Yeah, so this is the things, like in simple words, the guess data, the data is coming, so data put it into the server, then it will be in the different table. SQL, you will do write the SQL query to join, merge, and those table, and you will get the final list of table from that. After do that, you will do a lot of data cleaning, deduping, missing value, and all those things. Maybe your primary key is missing, you will not allow those variables in those records in your database. So all this data cleaning activity will do, you will get the final model. Then you start doing the your uh, like EDA kind of thing for machine learning things for with this data. So if you don't know how to prepare a SQL query, how much good machine learning, because nobody is going to give you the data. You have to prepare your own food. Okay, that's the basically key. Selection of the variables, as I mentioned, there is no limit basically. As much variable as you can, provided you will not fit go for the overfitting kind of scenario, like your training accuracy is very high, very, that's why you should, that's what I keep on telling, Occam's razor. This is the fundamental principle of any kinds of machine learning or statistical modeling thing. You keep on increasing basically your number of variables, if keep on increasing, your training accuracy keeps on increasing. But when you test basically outside, your model will not be able to capture the variation of the in time, like out of time sample or in time validation sample. That means the model tries to remember the noise, but model is unable to remember the basically signals. So that means your model is not generalized well. It is only fitted for this data. That's what the overfitting. I saw a lot of definition is overfitting, lot of things. It's as simple, right? It's try to remember only me. If it sees any other person, like a child, it's a simple like a child. A child knows who is their mother. If you show anyone other, it don't know who they are, how much relation it has. It is as simple as that. That's what to call overfitting. Okay, so that's why like no number of limits in the variables. Selection of variable depends purely on the modeling sites. Okay, because how much model you want to do, that is up to you. Irrelevant variable has to be dropped. That is the fundamental things. Variables with large missing value needs to be dropped. So basically that means the first things which I do is this step. Variables which is having high missing value more than 10%, I dropped it. Variables which having the constant value or quasi-constant. Quasi-constant is basically a new machine learning concept, which is a lot of people are these days. I see that quasi-constant is basically 99%. See, how do you find out the basically constant value? Constant value means you find out the distinct of that variables. Distinct value is 1. Okay, that means it is not capturing the variation. Remove it. Quasi-constant is 97% of the of the value of that variable is same, but rest 3% is varying. But still it is behaving like a constant, but it is not constant because constant has 100% same value. Quasi-constant has 97% same value. So it's like that's why the term is called quasi-constant. Okay. Next thing is basically creating new variables. How do you create the new variables? That's what this depends on how product knowledge, lot of your domain knowledge, product knowledge, whatever maybe you call. That's why still functional people. So in my company, a lot of ISI BStat people were working who are the god of statistics. In my company, a lot of IIT people are there. Yeah, and in my company, a lot of IIM people are there. Still now, I see that in every kinds of big organization related any discussion and those things, neither ISI people, neither IIT people, they are called for the meeting. Still that IIM people are called. Why? Because if your business problem, this is the fundamental principle of whoever is coming for the data science position in corporate. If your machine learning complex model is not able to solve my business problem, then it will go to shred box. As simple as that. That's what my manager said. I don't care if you give me a simple Excel based formula, I am okay, because that is solving my business purpose. If you give very complex mathematical research formula, but that is not giving, that is not saving my dollar value or increasing my top line revenue and as well as bottom line revenue, a bottom line, top line and bottom line, then it is no use. So so business understanding, stick to one domain, stick to learn that related variables. It will give you better knowledge while you deal with the machine learning problem. Okay, that is the, nobody talks about that. Domain knowledge is utmost important. So that's what, like how, what kind of variable you are creating, demographic variable, DLP, days since last purchase, how recent you bought, how much you are in the system, how much, what kind of product you bought in from the retail store, what kind of segmentation, whether you are a behavioral segmentation or basically you are in the life stage segmentation or any other kinds of segmentation variable you would try to buy. So you have to take in it. So these are the very few variables which are very significant in retail as well as the credit card business scenario. Okay. Variable transformation. These days variable transformation is not that much important, because in previously when you were trying to do the linear regression or any other kinds of regression, the typical fundamental hypothesis is that the relationship between x and y is linear. What do you mean by linear? One unit increase in x in mathematically, if I, let's say, if I try to explain those things to my father or mother, what is linear? Lot of people are talking about linear. What is linear actually mathematically? If y is increased by 1 unit, our x should increase by 1 unit. That means in our childhood days, if I go back, like a coordinate geometry, tan theta, that means the line will always follow the tan theta. Theta equals to 45 degree. Why? Because how do you find out the slope of a curve? Still old days things. Del y by del x. How do you know? Don't know del y? Delta unit change in y. How much is the delta unit change in y? 1 unit. 1. Divided by delta unit change in x. How much is the change in x? 1. So 1 by 1 is 1. So tan theta equals to 1. That means theta equals to 45 degree. So that means it should be towards the, like this. It is the x, it is the axis, y axis and x axis. It should be this. So that's why it should be linear. Now, so to make the things linear, a lot of people do probably x versus y is not linear. Probably x square versus y is linear, because x square I can call it as a z, some other variable, to make the linear. Okay, so that's all called basically linear and non-linear relative factors are coming. Okay, how much? Okay, fine, I can go a little bit, yeah, less. Uh, so in that variable transformation related things, a lot of statistician has given a lot of things like Box-Cox transformation, which is the very famous, like x to the power lambda minus 1 divided by lambda. So lambda vary from -5 to +5. Okay, so you keep on basically varying. So that is called power transformation. Another kinds of very common transformation which we use in our industry called Johnson variable transformation. Johnson. So whenever your data is not following the basically normality, then you should do the Johnson transformation and do the variable transformation. So here I have given the typical few kind of transformation like square, square root, log x. Log x is basically very useful, which we do in our industry frequently. Why we do log x? Basically, when you see that error is very high, when you convert into the log form, your error is in shrink. Again, you develop the model on shrink data, then you expand it. A lot of time we use. So so in typical demand supply kind of use case, we use the log y versus x. So we, instead of y versus x fitting the regression equation, we take log y, then fit the regression on x. Okay. So treatment of the missing value. So missing value treatment is very important. This is also there is no hard and fast rule for that. And in industry, at least me, I don't know everyone, so I should not talk about industry, but at least me, I never do statistical imputation, which seems very awkward. Like, why he is talking like that? This is true. See, first of all, one has to be understand, if your variable is missing. So missing can be happened because of the measurement error in statistics. Measurement error means basically my measurement unit through which I am capturing the data, it is unable to capture, or it is basically called, or it is by default missing. Okay. So missing value has lot of pattern, which is called missing completely at random, missing not at random, missing at random. So lot of things are there. So is it actually it is actually a zero value? That means, let's say I am, as a simple example, in a typical retail case, because here we are discussing about retail industry. Let's say I try to find out, I have 100 customer. Okay. I have 100 customer. I want to notice those 100 people next 30 days, whether they are coming to my shop or not. Now every customer will not come every day, right? So that means what you will do is, you saw the missing, oh, missing, I have to impute with mean value or median value, or some kinds of mode value, or whatever, maybe some other statistical or interquartile IQ or method, or box plot way, any could be. But then what you have done, basically the customers whose visit should be zero tagged, you have imputed them with, let's say, 4 visit. That means you are injecting bias in the data already, right? Unnecessary bias you are injecting. You should be very good knowledge of the domain. That's what I'm saying. Had I been in your place, what I will do is, I will find out, oh, this is a visit variable in retail, right? So that means it should not be replaced with some other value, because someday person can be missing, right? Person visit value can be missing. So what happens is, I should replace with 0. So there is no, that's what I'm saying, is very easy. So missing value treatment is a big analysis in our domain, finance domain. Okay, it is not that you do some kinds of imputation, whatever value, and let's go. No, if you put garbage value, you will get garbage out. Giving input as a garbage, getting output as a garbage only. So that's a lot of thinking. So probably today's 1 hour will give you in a different direction, that we should not learn algorithm just for showing, oh, this much algorithm I know. First and foremost, we should learn the fundamental mathematics behind that. It is utmost important. If you understand ABC, then you can form any sentence. Present tense, past tense, future tense, any kinds of thing. You need not to separately learn present tense, past. I believe in this principle. Maybe some data scientist, whoever has given, they will talk about like we should know this, that, but that is their view. But if you ask any kinds of researcher, I am talking specifically for the students, not for the researcher, because they are more knowledgeable than me. I cannot comment on them. So, but the students I am talking, like whoever wants to go to the corporate field, or want to do some kinds of research, or talk to any professors, they will talk the same thing which I am talking. You just remember me. Anyway, less than 1% missing, basically delete the observation. Deleting observation is also, these days, a lot of people are not doing. That is okay. I am giving all the options to show you, but this is the last case. Mean imputation, where to do mean imputation, whether your mean is basically dependent on outlier. So if your data has outlier, if you do mean imputation, don't do. better you will do basically median imputation. Regression based imputation, like some other variable is missing, you know that that variable is dependent on that. Then you form an equation, and you try to impute that value with the help of another value. More than 10%, I basically drop them. I don't do anything, because now machine learning you need not to do, because in data in the decision tree and all those things, there is something called surrogate splitting. So it will find out its replica variable, and it will try to like segregate the data based on that way. This is splitting the data based on that way, the decision tree. So that is called surrogate splitting. Okay. So now next thing is basically, sorry, how do you do the validation and thing? See, let's say that your population good and bad means this is your one, this is your zero. Always we should try to do the sorry. Always we should try to do the like stratified sampling instead of, like, what happens is, let's say your number of ones is rare event modeling, where the basically rare event things, like where your event rate is very less. What will happen if you take the arbitrary sample from here? Probably in the entire data 1% one is there, but whenever you take the training and testing splitting, basically you may take probably majority of the 1% here in training and testing very less. So you're testing it, so 1 versus 0 proportion, in both the cases it is not coming same thing. So that's why you should not do those things. Okay, so that's why you should do this basically stratified sampling, where you should split the data in such a way that if 60% data is here, 40% 1, 60% 0, 40% 1, 60% 0, 40% 1. So you combine them, this 60%, this 60% with development side sample, this 40%, this 40% as a validation sample. Yeah. So raw correlation, this is still you can do. I do basically VIF checking instead of correlation, because correlation it's very difficult to, because you have a 2000 variable, it is very difficult to see the variables, because 2000 by 2000 matrix it will form. It's very difficult to see. But whenever you have a very less number of variable, you can do that correlation analysis. Yeah. So I better basically do the VIF checking and all those things, because correlation is a pairwise correlation. I cannot know effect of one variable having the presence of another variable. Fine classing and coarse classing. This is a lot of people are doing for the interpretability or the better feature creation. Let's say I have a data of age. Let's say age is a variable. Okay. Now I see that different binning I created, and I try to see that which bin is basically created better in terms of dependent variable. Okay. Now, whenever I am doing basically binning, I see that 10 to 20, that binning is not that much significant with respect to the dependent variable. 30 to 40 also not things. So what I will do? Can I keep the separate dummy one hot encoding for all those bin? No, right? I will club them. How do you know that which bin to be clubbed, which bin not to be clubbed? Answer is this: fine classing. So it is the process that allow us to determine what characteristics are worthy of consideration in model development. So each model is investigating to determine good or bad trend. That's why with respect to the dependent variable, we find out that bin and which to merge, which not to branch. So that is called weight of evidence method. So which weight of evidence are coming similar, that should be merged. What is the weight of evidence? Some formula is there. See, formula remember nobody wants. Formula remember is basically log base E percentage of bad divided by percentage of good. That is the weight of evidence. So every bin you will find out some value. Let's say 10 to 20. Weight like weight of evidence is 0.2. 20 to 30, 0.5. 30 to 40, 0.2. 0.25, let's say. So that means 10 or 20 is not that much important. Club them. Once you club them, and then you plot the basically log percentage of one versus all the bins, it should be a monotonically decreasing order, or it is the same. Okay. The same thing, fine classing, coarse classing. So if you combine the weight of evidence and better to do the information value. So this is information value is our typical machine learning use case of variable importance, which we get. How do you calculate information value? Same, percentage of bad divided by percentage of good into log of individual, that I am talking about individual bean wise. Okay, percentage of bad divided by percentage of good sorry, into log of to the base e percentage of bad divided by percentage of good. For each bin you add the things, then you will get the information value for that. Now this information value is used for a feature selection. How? If that feature information if the information value for that feature is less than 0.03, not predicting, do not consider them for modeling. If it is between 0.03 to zero point 0.1, it is considered for modeling. It is greater than y, very good predicting power, so use for the modeling. So in general, if greater than zero point 0.3, people are taking that for the modeling for that variable. If it is not, then discard the variable. Okay. So dummy correlation check, that also you can do the same thing like the way you are saying VIF and all those things. The same way you can do that dummy correlation check. Yeah. So this is what I do. Like stepwise selection, it has two methods, like forward selection, backward selection. Okay, and both forward and backward combined, which is called stepwise. So in general, what happens is uh, I prefer to do in general, like in machine learning. Let's say we are thinking from the machine learning, because I am talking about the machine learning because a lot of people are majorly not aware of the statistical part, but maybe they are aware of the machine learning thing. Sorry. So how do you know that this set of features is a very good features? What we usually do is we start with 1000 variables. Okay, you find out, take the 1000 variable combination, you find out their area under the curve. Okay, then you drop one variable, then you check if I drop that variable, then my area under the curve, dropping that after dropping that variable, my area under the curve improves drops drastically, or it is remain the same. If it is remain the same, that means that variable is not that important. Again, drop another variable, find out the AUC. So this is the similar like a stepwise selection method. That's why I believe, that is my belief, this machine learning is old wine in a new bottle. For me, I don't see any difference between machine learning. Ha, the good part of them, and then you say that why people are talking about so much machine learning, because it's easy to use. In statistics, lot of assumption you have to follow. If the assumption will not follow, you will not be able to use it. But in machine learning, there is no distribution assumption, so it's very easy to use. That's why it gained popularity. Number one. Number two is in statistics, if you want to use any kinds of non-linearity, so if your dependent variable has a non-linearity with respect to the independent variable, it's in the model is not performing well. Though we have a technique called spline based regression. I don't know how many of you heard about it. So it is basically, if for every bin we are creating, so let's say 20 to 30 one regression equation, 30 to 40 one regression equation, 40 to 50 like that. So but it is very difficult to fit the equation. Another is called polynomial equation, polynomial regression. So those are there. It is not that it is not there, but yeah, that machine learning is giving better accuracy in terms of if there is a non-linearity. So we are using. But I am thinking everything already there. They are just rebranding it as a new wine kind of thing. Okay. Anyway, so that's what, like you keep on dropping in every iteration, you find out the area under the curve, you drop one variable, find out the area under the curve, drop variable, and you will come to a point where dropping a variable will remove the area under the curve drastically. then you will not drop that variable. You will add the variable again and you will say that this is my final set of features. Stepwise regression is also doing the same thing. Okay. Multicollinearity. So multicollinearity is basically like VIF is 1 by 1 minus R square. R square is basically when you use that variable as a dependent variable and rest of the variable as an independent, what is their coefficient of determination. So 1 by 1 minus R square is basically 1 minus R square is called tolerance. So VIF is 1 by tolerance. Tolerance is 1 minus R square. R square is basically 1 minus coefficient of determination. So that's what this things is talking about. Okay. So basically what you will do is in your typical logistic regression case, you will find out the probability value whose value is greater than zip. So this is the another thing. Like a lot of people I have seen that once they feed the model, they directly go to the variable level importance. No, first of all, why should I go to the variable level if my individual, if my overall model? So had I been in their place, what I will do is this is called global hypothesis of the test. I will not see the variable level importance at all if my model is getting rejected here. Okay. So if my model is getting rejected, my model is greater than 0.05, I will not go variable because this model, the hypothesis is all betas are 0 in typical logistic regression scenario. Okay, all betas are 0, which is very logical, right? Because if all variables are not 0, then I will check which variables are important, which variable is not important. If all variables are already 0 from there, then why should I go to the individual variable level? So this is the test which is called overall the model is effective or not. So all betas are 0. Now, if the all betas are not 0 here like that, it is 0.05. That means that all betas are not 0. Then I will check, okay, some variables are, that means important. Now I will go to the which variables are basically important. Okay, then I will go to the individual variable level. I see that that variable y, it has p value, world chi-square value is basically greater than 0.05. That means this variable is not that important. Then I will go. First, I should go do this. If I am not unable to understand, then it is your problem. So every interpretation you have to understand. Every interpretation you have to interpret. Okay, then I will go to the variable level. I will find it out. I will run again. I will check whether the model is doing good or not. Okay, it is coming in SAS. It is like that. Another thing, tool does not matter. A lot of people are thinking Python programmer. I see that in LinkedIn. Python, no, machine learning using Python. What machine learning using Python? Python is a language. Tomorrow Julia is coming, another programming language. Then you will learn machine learning with Julia. So your subject will not change. Coding keeps on coming and change. Your logic should be, you should know how to write a code with logic. Today you are writing, see, I started with career my SAS. Then I moved to R. Now I am using Python. So programming keeps on changing, but the logic is same. Still people are understanding that way only. Yeah, so this is the basically like a coefficient of stability. What happens is this is very important. Model validation. How do you know your model is good? Try to understand this concept. So let's say you get 4 variables, which is very important from here. Let's say from here you get four variables, which is very important. Now you know that variable 1 is negatively correlated with y. Variable 2 in the development sample means in training data. Variable 2 is basically positively correlated with y. Variable 3 is basically positively correlated with y. Variable 4 is also positively correlated. Now, if you see that variable y negatively correlated in training and in time validation data, test data, variable y is positively correlated. If your sign changes, that means whatever the model you have developed, it is not stable. How do you do these things in machine learning? Machine learning interpretability, it is also there. There is something called SHAP plot. Okay, SHAP has a basically good feature like this kinds of thing. So SHAP has a like a red color bar chart, horizontal bar chart. If it is red, the bar color is red, that means it is positively correlated, and it is negative. See, same principle. That's what I'm doing, the traditional versus machine learning. So if it is a red, that means positively correlated. If it is blue, it is a negatively correlated. Now you develop shape plot for the training data. You develop shape plot for the testing data. If you see that both are changing, that means there is some problem with the data. Your model is not good. Okay. Case statistics. This is a very fundamental problem, things which we need to report to the RBI whenever we are developing model in our thing. So RBI people like asking like, what is your case statistics in your model? Case statistic, what is case statistic? This is the case study. Case statistics talked about how much good separation power if in your model. How much is the basically cumulative responders, percentage cumulative responder versus percentage cumulative non-responders. So K's value should be 30 to 75. If it is below that, problem. If it is greater than 75, then problem. Okay, so this is the basically, I am just giving what kind of things you should do as a suggestion. Rank ordering, this is what I am talking about. Rank 1, this is the actual income. You see that it keeps on decreasing. Your predicted values is also keeps on decreasing for income. Your actual values also keeps on decreasing. Then it is holding true. Either it is monotonically decreasing with rank, either it is monotonically increasing with rank, then it is holding. So if it is happen here, it is monotonically decreasing, here it is monotonically increasing, then problem. Then your model is not good. Still you can do these things in machine learning. Every day we do. Lorentz curve. This is the basically what our business people wants to see. This is called no model. If there is no model, that's what 45-degree chart. 20% if I target, 20% respondent I am able to capture. 40% if I am able to target, 40% respondent I am able to capture. Now this is my model, your red one. So that means what it is talking about, if I am able to target 40% of the population, I am able to get 60% of the responder. That's the good part. That means if I don't use the model, I get only, I am able to capture 40% of the responder. If I use the model, I am able to capture 60% of the responder. That means if I use the model, I will be able to capture 20% more responder than if I don't use the model. So I will convince this way, please use my model. This is very important in marketing scenario. How do you explain that my model is good? This is the basically actual versus predicted curve. This is your actual data, how it is coming in the predicted data. If whether it is following the same pattern or not. If it is not following, then your model is not good. All this should be a validation. Nowhere in this LinkedIn, you search Google, nowhere it is written. It is all the industry practices. Thank you. I am open to any question.
Okay, so once again, I'll unmute all participants. Actually, you're
Yeah.
muted. Okay. Yeah, so Sir has busted many myths in machine learning, AI, and lot more, and he gave us a very good stress on how important the statistical learning is. So that was a wonderful session, sir. So
Thank you.
participants, if you have any queries, you can please ask. And as I introduced you in the beginning, like Sir's not only an IT guy, like he's also into lecturing. So, like, so you could make use of his expertise. And if you have any queries, anything to ask, please feel free to ask right now.
If not, you can take my number also from Divya. You can ask, call me personally. You can ask. That is also
No, sir,
no
it is
problem.
very informative and important session for us.
Thank you. Yeah, thanks a lot because I just want to see like whom with whom I at least I am talking. Yeah,
Thank you, sir. Thank you, ma'am.
thank you. So if there is no other question, then we will be